Hi, welcome to Elonix. In this tutorial, we'll make an electronic piano circuit on a breadboard using 555 time IC. We will also learn how this circuit works later in this video. For the list of components required, link to the circuit diagram, or links to the previous and upcoming projects, please go through the description below. I'll be using this column as positive rail and this column as negative rail. Place 555 timer IC on the breadboard with its notch facing up, and these are the pin numbers. Connect pin 8 to positive rail and pin 1 to negative rail. Next, connect pins 2 and 6 of the IC to each other, and similarly connect pins 4 and 8 to each other. Now place a 1 kilo ohm resistor between pins 7 and 8 of the 555 timer IC. Next, place a 100 nanofarad capacitor between pin 2 and negative rail. Now place a momentary push button switch on the breadboard. I have placed it such that the pair of interconnected pins are in this direction, and both the pairs will be connected to each other only after the push button is pressed. And you can find out which pair of pins are interconnected by looking at this symbol. Next, place a 4.7 kilo ohm resistor between pin 7 of the 555 timer IC and one of the pins of momentary push button switch. Now connect the other pin of the push button switch to pin 6 of the IC. Next, place another momentary push button switch on the breadboard with its orientation similar to the previous one. Now connect one of its terminals to the terminal of the previous push button switch, which is connected to pin 6 of the IC. Place a 1 kilo ohm resistor between the other terminal of the push button switch and the terminal of the previous push button connected to a resistor. Repeat this for as many times as required. So now one terminal of all the push buttons are connected to pin 6 of the 555 timer IC, and the other terminals of push buttons are connected to increasing values of resistors. For example, this push button connects pin 6 and pin 7 via just 4.7 kilo ohms of resistance. And this push button provides a resistance of 4.7 kilo ohms plus this 1 kilo ohm, which totals to 5.7 kilo ohms of resistance. Similarly, this push button will provide a resistance of 4.7 plus 1 plus 1, which equals to 6.7 kilo ohms of resistance. Now place a 10 microfarad capacitor with its positive terminal connected to pin 3 of the IC and a negative terminal connected to an empty row. Next, place an 8 ohm speaker between the negative rail and negative terminal of the capacitor. Finally, connect the power supply, and the electronic piano circuit is now ready. The core principle of this circuit is that we can hear sound because the speaker diaphragm vibrates. And we are able to produce different tones by changing the number of vibrations of the speaker's diaphragm per second. For example, for lower frequencies, the number of to and fro motions of the speaker's diaphragm per second are less than that of the to and fro motions for higher frequencies. And these vibrations are generated by turning the output on and off continuously for as many times per second as required. In the LED blinker circuit we made in one of the previous tutorials, we adjusted frequency of the output by changing the values of resistance using a potentiometer. And this is a short animation for the same. You can refer to that tutorial for more information on how this cycle happens. In brief, the frequency of the output depends on how fast this capacitor charges and discharges, which implies that if we increase the value of this resistor, the capacitor takes more time to charge and discharge, and so the frequency reduces. Similarly, if we reduce the value of this resistor, the capacitor charges and discharges quickly, and so the frequency increases. Here the frequency is less, so we are able to see the actual blinking of the LED. But for this electronic piano circuit, we need tones with higher audible frequencies. So we used a smaller 100 nanofarad capacitor instead of the 10 microfarad we used for blinking LED circuit. And in order to get different tones, instead of using a potentiometer for changing the resistance, which is responsible for changing the frequency, we directly made an arrangement of different resistor combinations. And as discussed previously, pressing different push buttons will provide different resistance values between pin 6 and pin 7. And the resistance between pin 6 and pin 7 increases as we press push buttons away from the first resistor. As a result, we get different tones for different resistor combinations. And this is the formula for frequency of the output for any given values of resistance and capacitance. In our circuit, the value of R1 is 1 kilo ohms and the value of C1 is 100 nanofarad. So this is the final formula for frequency after replacing the values of R1 and C1. You can also rearrange this formula for obtaining the value of resistor you need to use for any frequency required. Thanks for watching, do subscribe and have fun.